I am Kevin Mahaffey. This is my colleague John Herring, and we're here today to talk about mobile applications. It's great to see a whole mobile track here at Blackhat this year. It's certainly a sign that mobile applications are more and more important in everyone's daily lives, and happy to talk about it. So you can find me on Twitter, DropAllTables. Generally our background is we like to talk about mobile security, RFID, privacy, things that matter to people, new technologies. We have a bent for wireless technologies. We've talked at Blackhat, DEF CON, Blue Hat in the past on a variety of topics. And most of all, it's fun, and we hope that some of you guys here today can take what we're talking about and apply it to your personal safety, where you work, if you're a software developer, and building better products to protect people. And ultimately, that's our goal here.
So hopefully a few of you saw our talk last year. We talked about hacking the iPhone and a number of other different mobile platforms. Kevin, myself, and Anthony Lineberry talked a little bit about fuzzing mobile. So instead of looking at the mobile OSs in and of itself, what we're going to be looking at is mobile applications. And really what we've been seeing is an explosion in adoption of mobile applications. And in doing so, we asked ourselves, okay, these are actual practical things that people are interacting with every day. Given that, are there actual practical attacks and vulnerabilities that can be discovered, and things that can be learned both for the OS vendor perspective as well as the developer perspective, more importantly. So let's kick things off with a vulnerability.
In the beginning, there was vuln. So as you guys know, well, some of you may know if you were here for Anthony, David, and Tim's talk on these aren't the permissions you're looking for. Android has a logging subsystem. It's much like other logging systems, but this one is it. It's accessible via logging APIs or via device, and it requires permissions by an application to access it. Most applications, you use it as a typical debugging system, but there are vulnerabilities that can happen when applications put sensitive information into the logging subsystem and other things can pull it out. So for example, one location disclosure vulnerability that affected Android that Google has fixed in 2.2 Froyo. Their security team was really great about pushing out a patch as quickly as possible. And effectively what it is the location manager, which is the way you access location on the device. It's a system level service. Discloses two key variables. One is the cell ID, and the other is the LAC, the location area code. These are GSM parameters that you can use to locate a person. And so what happens is the location manager logs these variables into the general system log, and an application that doesn't have location permissions but only has read logs permissions can get access to them. So effectively, this is an information disclosure problem.
Right, and conceptually, this class of vulnerabilities, what's so interesting about it is the idea that many operating systems, and Android does a good job of this, notifies the user of what's happening. They say, okay, these permissions are being requested. Now imagine a world where applications ranging from something that's looking at your location to actually credentials of a sensitive application, which we'll talk a little bit more about, could be accessed by an application that doesn't request permissions. So a great example of this type of vulnerability, if everyone saw earlier this week, there was a problem with Citibank's iPhone app actually recording certain aspects of the credentials of the banking application to places that might be accessible either on the device or if synced with the PC on the PC. Now this is a little bit different than what we're talking about with Android, but if you look at conceptually the problem, imagine a world where a financial institution has an application that's inadvertently logging the banking credentials to the log files on the device, and then another application that doesn't have access to any sort of information can actually go grab your banking credentials from this log file and take those and use those potentially maliciously. So you could see that in practical terms, if someone is actually looking in these log files and application developers are not being intelligent about what they're doing with these log files, the ramifications could be very, very significant.
So the vulnerabilities we had just talked about have been previously disclosed, and we're going to talk about a new vulnerability that we came across. On Android, many applications log URLs that they hit to the system log. And this actually includes the Android browser in certain circumstances. On this page you can see two such log entries. The first is what the browser would do if I typed in www.blackhat.com into the search bar. And the Android has actually a really cool, what's it called, an intent system that basically allows you to kind of swap out who handles any given action. And this is the intent being sent by the browser to the system as a whole to basically resolve a search. What the vulnerability we're going to talk about today is what happens when a third-party application, let's imagine this application uses a web view to implement, excuse me, to implement sensitive functionality, and it starts logging URLs. Let's go to an example, and I think some of you will start to see what happens. So let's imagine we have an app. This app is a standard account access app. You might imagine Facebook or any sort of app that you might log into an account with. It has a web view, and when you open the app, it has a login form. And so what happens there is that when you first open the app, let's imagine this company has a single sign-on system. So the app would send an HTTP request to sso.company.com/form. The server would respond with the HTML to render that form. The user click, types in their username and password. They click OK. And the app will do a post to the single sign-on system in that company. Remember, this is HTTPS, so there are no problems with SSL, right? Everything is safe, hopefully. But let's assume that the username and password is correct, and the server will say, OK, the login was OK, but it says, OK, now that you've signed on to the single sign-on system, we want you to redirect to app.company.com, and we're going to give you a session. And that session is authenticated by a secret key, and we're going to give you that in the URL we give you back. So the application gets this redirection, says, OK, I'm going to go get this URL. Now the server responds with welcome to your account and might set some cookies, so on and so forth. What happens when we look at this from the log side? We see get URL, sso.company.com/form. Seems reasonable, right? We see post. We see the post data, or we at least see the URL of the post. Then the redirect, we see the redirect get URL with the secret token. And remember, any application with the read logs permission can see this. So what would happen if a malicious application reads the logs from the device, uploads it to somewhere, and then somebody uses Control-C and Control-V? Well, we found an application in the wild that used get parameterized session IDs, and all you do is paste it into a web browser, and you are fully 100% logged in.
So just so that everyone's clear, you grab this piece of text, paste it into a browser, and you are logged into the person's account.
Not good. So what's the point? App developers in the room, please don't put sensitive information to the logs. If you're using it for debugging, great. Run through. I mean, even great software houses, people who know what they're doing, kind of haven't quite realized that logs are shared property on a lot of mobile platforms, so don't. Also, web developers, especially if an application is logging or interacting with an API, try to use cookies or other sorts of ways of putting sensitive data places, throwing them in get parameterization, especially if we're talking between applications on a mobile device. That might get logged. It's just safer not to.
One thing I might add just really quickly, we're seeing more and more enterprise deployments where folks will build an application for their own company or own internal uses. This is especially critical if this were to happen where the credentials are allowing you to access enterprise resources. You could imagine what might happen if you build an in-house application that's deployed to smartphones for your own enterprise that was compromised through log files, for example, that would then allow a third party to access enterprise resources. So you could see ranging from a consumer with their own, a social networking account or a banking account, for example, to actually getting through the firewall and accessing enterprise resources.
So the vulnerability, this is all fine and dandy. How do we know what apps in the world have vulnerabilities like this? If we do find something in the wild, how do we know who exploits it? And I mean, that's an almost intractable question. And so we asked that question. What if we could, say, pose a question to every single app that we can get our hands on in the world for mobile? And a few months ago, we started what we're calling the App Genome Project, which is basically the goal is to identify as many mobile applications as we possibly can and be able to ask them things, sometimes private things. So what is the App Genome Project, you might ask?
So really what we've put together is, as we understand it, the largest ever mobile app data set in the context of security. So we've encountered approximately 300,000 mobile applications, specifically across the Android operating system and iPhone OS, iOS, by looking at both the iPhone App Store and the Android market. We've dug in and really deeply analyzed about 100,000 free applications and looking at things like metadata and application binaries to actually get a sense for what's going on within the context of these applications, looking at trends within apps that could be suspicious potentially or might be doing something like using a vulnerability or accessing private information, and then being able to use that information to almost fingerprint an app, look at the genome of an app, and ask what other apps share that characteristic to, in a proactive fashion, be able to detect those and respond to that threat.
And we'd love to download paid applications as well. If anyone wants to write a check, I'll be available right afterwards to accept. So quick overview of what we're going to talk about today. We're going to talk about a little bit, why mobile apps matter, why you should care, or why you shouldn't care. What our motivations for, what our goals are for the project. This won't be the last time we talk about this. How did we build it? What's under the hood? What did we find? We're going to tell about 4 stories. I think they're going to be good stories. How do we use the App Genome Project as a security response tool? And I think a lot of you here who are in security response organizations will see how this can definitely help. And what's going to come in the future? We're going to try to whip out our crystal balls. First, why do we care about mobile apps?
So mobile apps matter, and we could talk about why they don't matter also. So I think it's a very obvious to everyone that really smartphones are the computing platform now. It's the future of computing in terms of the just general number of folks who are actually going to be using this as their primary computing platform. It's funny, I look back to when Kevin and I were talking about Bluetooth hacking in 2004, 2005, and the Razr was the most popular device because it was thin, and that wasn't very long ago. And you look at what's changed since then, basically everything. So not only has this computing platform been adopted, and broadly, mobile broadband data has absolutely exploded, which has led to this trend of applications being used, native applications. And we're seeing more and more of the discussion of native applications versus the web, for example. But for the immediate future, absolutely, we're going to see native applications being the primary way that people interact with applications on the mobile platform. And not only are people downloading apps, the people who do download apps are doing so at a voracious pace. So we're seeing on average about 22 apps per smartphone. I can tell you that we've seen a number of data points where people may have hundreds of apps on their smartphone, and especially in a world where a lot of new smartphone users are unsophisticated, this is a brand new platform to them, they're downloading apps just because it's exciting, not even really thinking about what's happening on their device or what might happen in the context of these apps. And most importantly, we're finding apps access sensitive information and can actually cost you money, incur financial damage. So bank accounts are a great example that we talked about. SMS premium billing or premium phone calls. We have actually seen instances of malicious applications on various platforms leveraging premium billing mechanisms like this that one of our friends, Miko, is actually going to be giving a talk on as well. That's a really interesting subset of the types of ways folks can monetize attacks. And then email and text messages, sensitive information.
I think the power of monetization on mobile, imagine if every PC in the world had a UDP protocol where you can send a single packet and money went flying around. I mean, that's pretty powerful from an exploitation standpoint. That's what reverse SMS billing is. So why should we actually care about this? I mean, first and foremost, standardized APIs are making it easier and easier to actually create practical attacks. So instead of